Okay, let's kick it off. All right, everyone. Thank you for joining us this month. We today are going to focus on Lakehouse Automation with Redshift and the Apache Airflow. Also, we'll talk about some of the latest talks and the new services and features that actually came out of the Reinvent conference just last month. So December 2021, we had Reinvent in Las Vegas. And so Antje and I have collected a set of slides, and we'll be presenting those as the second talk. And so we'll just quickly go through all the latest features, not just from machine learning and the analytics, but also best of for compute and serverless and the application development and some other areas. So we'll do the, I think this is the first recap I've seen anyway. I think there's a series of recaps coming out later this month from a different channel within AWS. But so you'll actually be getting the first recap that I know of anyway. And so, yeah, Antje, do you want to say hello? Where are you broadcasting out of, Antje?
Yes. Hi, everyone. Thanks for joining us here in the first meetup this year. I have, in the meantime, relocated from Germany to the US, so I'm broadcasting now from Mountain View, California.
Sunny Mountain View. Awesome. And why did you pick Mountain View, Antje? Why didn't you pick San Diego or
right? Yeah.
Austin, Texas?
I know. If you have good recommendations out there for the next place to go. No, I think it's a really nice area here, and I definitely wanted to trade German winters for a little bit of California sunshine. That's for sure. And also, I hope to have an exciting network here with ML startups and meetups. So looking forward to explore the tech scene here around Palo Alto and Mountain View as well.
Yeah, I mean, I remember when I first moved to the Bay Area, I would go to any Starbucks in Mountain View, Palo Alto, and hear deals going down. And it was the first time I'd heard of a SPAC and, you know, all the terms RSUs and everything. And it seems like there's like VCs just all over the place in that area. So yeah, like you'll get to meet a lot of folks. And hopefully the meetup scene starts up again in person, getting kind of anxious. But the startup scene very much is super active. As I think we all know, there's still quite a lot of funding flowing into the Bay Area and of course other cities throughout the world. So seeing a lot of activity that certainly has not slowed down. Gary, do you want to introduce yourself? And I guess if you want to take over, I posted a couple links, and Gary, yeah, take it away, buddy.
Sure. Thanks, Chris. Thanks, Antje. So I'm the polar opposite, no pun intended, of Antje. Sometime during COVID, we moved from Palo Alto, Sunnyvale, back to New York. So we're in the midst of a snowstorm here. So I think we have one of those German winters going on right now. But yeah, let me just share my screen. Move my picture of myself out of the way here. Can you see that okay, Chris and Antje?
Yes, we can see the slides.
Great. So I'll start off. Yeah, again, so I'm Gary Stafford. I'm a senior solution architect at AWS. I'm also a member of our analytics technical field community. So I spend a portion of my time working with digital native customers, and then maybe half of my time specifically working with customers that are building analytics solutions on the AWS platform. Today, I'll just start off, and I tweeted it out the other day, a little funny. When I was working on this presentation, the original title had the word Lakehouse in it. And I noticed now that the AWS documentation, not that term isn't used anymore, but we've kind of removed it, and we now use the term modern data architecture. So I switched out the title to be DataOps for modern data and architecture. So if anyone's confused, that's why. I'm going to do a brief demonstration and presentation today, and it's going to be based on a series of 2 videos and a blog post that I did at the end of last year, and they fit together in a series. They start off with a blog post talking about DevOps, or specifically GitOps for data ops and for data analytics. So ways to streamline and automate and make your development of resources for your analytics pipelines more efficient. And then I did a series of 2 videos. The first video using those DevOps techniques, and both of them based on Apache Airflow primarily. The first one building out a data lake on AWS with Apache Airflow. And then the second video was I used the word lakehouse, using the Lakehouse Automation on AWS with Apache Airflow. So using Apache Airflow and some other tools to programmatically load and unload data from Amazon Redshift, which is Amazon's cloud data warehouse, into an S3 based data lake using Apache Airflow. So for the next maybe half an hour, I'm going to briefly introduce the GitOps for DataOps topic, and then speak to the Lakehouse Automation on AWS, and hopefully if we have time, do a brief demonstration. So just a quick agenda, I just mentioned a few of the terminologies and technologies that are mentioned in the series and that I'll be talking about today. I'll briefly mention the data source. Chris and I and Antje were just talking before this, and I can share the link at the end, and I think Chris shared it. The GitHub repo, all the resources that I'm showing today are available on GitHub, and the deck is also available at the URL that Chris mentioned. And the data source that I'm using is also available, and there's a link to it on the AWS platform. And then I'll go in a little deeper into the architecture and the workflows, focusing primarily on the first and the third part of the series. And then if we have time, do a brief demonstration to show you how it all fits together. So just to really quickly, a few terminologies. I won't go through all these in depth. I'm sure most of us are familiar with the term DevOps, the combination of software development and IT operations to shorten the software development lifecycle to provide continuous integration and continuous deployment. A term that maybe not everyone is as familiar with is GitOps, and I like this definition from Red Hat, is a set of practices to declaratively manage infrastructure and application configuration using Git as a single source of truth, and then using Git pull request to automatically manage and provision, manage provisioning and deployment. And in the first part of the presentation and demonstration, I'm going to demonstrate using GitOps to test and deploy our analytics pipeline resources. And then I mentioned DataOps. So again, I would imagine most folks that are attending this are familiar with that term or have heard of that term. But for those of you who aren't, DataOps, similar to GitOps and DevOps and MLOps, within that same set of practices and methodologies, is an automated process-oriented methodology used primarily by analytics and data teams to improve the quality and reduce the cycle time of data analytics. So I'll be demonstrating DataOps practices primarily using Apache Airflow, managed Apache Airflow today. And then I mentioned the modern data architecture in AWS, which is a relatively new term. And not that it's totally replaced the term lakehouse, but I think it's more inclusive of all the data sources that we as data analysts and data analytics teams use, especially on the AWS platform. So seamlessly integrating your data lake, your data warehouse, and your purpose-built data stores. And I think that's the key, that not all of us only work in a data warehouse or in a data lake. Oftentimes we're interacting with data that's still in our purpose-built data stores and our databases. So I think, in my opinion, that's a much more holistic view from an analytics lens of how we all work and how our customers work with respect to analytics. A few technologies. This discussion today is going to be very platform agnostic. I am using some AWS services, but by no means any of the methodologies that I'm discussing are specific to AWS platform. They could be an on-premise platform. They could be AWS, Google, or Azure. They're agnostic of any specific platform. I am going to, for Apache Airflow today, I'm going to use Amazon Managed Workflows for Apache Airflow, or Amazon MWAA, which is AWS's managed Apache Airflow platform. If you're not familiar with Apache Airflow, it is an open source platform to programmatically author, schedule, orchestrate, and monitor workflows on any platform. And I'm going to be using Amazon Redshift today. We're going to be talking about Redshift, which is AWS's cloud data warehouse. But again, you could replace that with any of the popular cloud data warehouses. There's nothing necessarily specific in this demonstration to Redshift other than it's just convenient being on AWS. We're using AWS Glue, which is our managed ETL service to discover, prepare, and combine data. And most specifically in this demo, using AWS Glue as an alternative to Apache Hive as a meta store. So taking data that's already in an S3-based data lake, which has been cataloged in AWS Glue Data Catalog as a metastore, the schema and metadata information, and using that to query that data and then read and write that data to a data warehouse. And lastly, GitHub Actions, which I'll demonstrate in the first part of the demonstration. And that's the first part in the 3-part series, talks specifically about using the GitOps practices, so using Git and GitHub and GitHub Actions to automate those different DevOps methodologies. So continuous integration, continuous testing, and continuous deployment. And that's all going to take part on GitHub. I have a public GitHub repo, and Chris put the link in there. So as I make changes in the demo, you'll be able to see those changes go through on that public repo. So those are just some technologies that are going to be featured today. The data source, really quickly, if you're not familiar, AWS has a ticket database, and it's an e-commerce platform. It simulates an e-commerce platform that brings buyers and sellers of tickets together for entertainment events. And it was built to demonstrate Amazon Redshift, but it would work with any cloud data warehouse, in my opinion. And it's just a simple star schema. It has 7 tables, 2 fact tables, and 5 dimension tables. So that's what I'll be using as a data source in this demonstration, and that's what's used in the series. So tables like categories, events, different venues, the users who are buying and selling the tickets, the listings, and then if there's any sales, those transactions and the data of those transactions, that's all part of the database that is being demonstrated here today. And again, there's a link there. It's a public data source that you can use. It's available from AWS. A very simple schema representation of it. And again, all this is available on the AWS Redshift documentation. So I have a series of 3 diagrams. I'm going to focus on the first one and the third one. And each one of these kind of correspond to one of the 3 parts of the series that I mentioned at the beginning, the blog post and the 2 videos. So in the blog post, I go into what I refer to as DevOps for DataOps, or probably more specifically, GitOps for DataOps. And what I mean by that is applying DevOps principles to resources, the development of resources that are used in our analytics processes. So those might be ETL scripts, specifically to Airflow. Those are directed acyclic graphs, or DAGs, which are written in Python. So Python files, Python DAGs, configuration files, so configuration for Airflow or for other tools that we're incorporating into our workflows. And also in this case, a number of SQL files. So specific to Redshift, I have a number of SQL scripts that are SQL files. Also for Amazon Athena, we're going to use, which is basically Presto or PrestoDB, a few more scripts, and then some Postgres SQL files. So all of those different types of assets, and there's obviously many more depending on the tools you use in your analytics pipeline, that as a data engineer, as a software developer, I'm going to be working with, I'm going to be developing, and I want to make sure that as I work with those, and assuming that it's not just me, that I'm working on a team with other data engineers, how do we apply DevOps principles like failing fast, right? I want to know if I did something wrong immediately. I don't want to have to wait till it gets deployed. So fail fast. You might have heard terms like pushing testing to the left. So making sure that I test my code as quickly as possible before it gets too far through our DevOps pipelines. Continuously testing that code. So the blog post goes through this process, and I have a diagram on the screen, and I'll jump into my ID in a minute and as part of the demonstration and show you how it works. But basically the concept is, as a developer, there is an existing GitHub repository that has all the assets that are part of our data analytics pipeline. As a developer, I would fork that repository. I make a series of changes to that repository. I perform automated testing locally. So even before it gets pushed to GitHub, before I do that commit or I do that pull request, then I'm constantly testing my code locally to make sure that nothing is going to break when I make that pull request. So running those tests locally with things like Git hooks, pre-commit and pre-push Git hooks, and then eventually creating a pull request to the owner of the repository or the owners of the repository. And when I create that pull request, what happens is on GitHub, using a GitHub action, so I mentioned GitHub actions before, so the first of 2 GitHub actions kick off, and they run a series of tests. Now those tests are arbitrary, and you may have different libraries that you use and different types of tests that you perform. I have a hypothetical or a typical set of tests that I run. And if you're wondering where some of these libraries came from or this concept, if you're familiar with Astronomer, who is one of the leaders in, I would say, managed Airflow, Airflow as a service. They have some great documentation. They have some great webinars and videos, and some of their documentation, they go into depth on how to test your DAGs. So taking some of that learning from Astronomer and apply that. So things like using Flake8 for style guide enforcement of Python, using Black, which is a very popular PEP8 compliant format testing. So running all the DAGs through a linting process. Then also testing for DAG errors. If you've developed it all on Airflow, you're familiar with DAG errors. And that one test alone will eliminate probably 50 to 60% of the errors that I typically make when I'm developing directed acyclic graphs or DAGs in Python for Airflow. Then I have I use PyTest to run a series of unit tests. And to be honest, the tests that I have, and again, they're all in the public repo, are more stylistic. So are there tags applied to the DAG? Have I used tagging? Have I used the proper naming convention? So imagine you have tens or hundreds or thousands of DAGs spread across multiple environments, many projects, many developers. So these unit tests really look for consistency in naming the different resources that I'm using as part of my analytics pipeline, making sure that I have tags, making sure that I have an owner, making sure that I have a notification process. So those tests are running through all that. And then I can also do things, and again, these are very simple examples, using something like SQL Fluff to do SQL linting of my dialect-specific SQL files that the DAGs are calling. And then even using something like JSON linting. Again, this is just a very simple linting example to check my Airflow configuration file, which happens to be in JSON. So assuming all that passes, I then either manually or automatically merge that pull request that was made by the developer or the owner of the repository would. And if that merge is successful, the second GitHub action then automatically syncs the DAGs along with all of the other configuration files to an Amazon S3 bucket. So if you've worked with Amazon MWA before, which is, again, AWS's managed Airflow, the resources, the DAG specifically, and anything that the DAG calls, any secondary files, are called from an S3 bucket. So this process has the ability, if everything looks good, if all the tests pass, if the merge of the pull request works, it'll sync that to S3, and then in about 60 to 90 seconds, those resources are available to my managed Airflow environment. So moving on, the second part in the series that I mentioned talks about building a data lake with a DataOps process, primarily using automation based on Apache Airflow. I'm not going to go too deep into this one. I'm going to talk more about the third one and demonstrate the third one, which is around the data warehouse with Redshift. But I just want to call us out if you're wondering, where did the files come from? Where did the data come from that I'm loading into the data warehouse? It's a result of the first part of the workflow, which is taking the ticket database, which I've split into 3 different database engines. So to simulate, why would I build a data lake? Primarily, I have multiple data sources. I want to aggregate the data from multiple data sources or enterprise systems and be able to perform analytics or machine learning on that. So in the second part of the series, what I've done is take those 7 tables and split those into 3 different database engines. And it simulates a typical, this platform might be a CRM system. There might be an e-commerce aspect to it. Maybe you're using a SaaS provider. So it tries to simulate not just a single data source, but a variety of data sources, and automating using Airflow, being able to use AWS Glue to extract that data, to transform that data, and then write that into an Amazon S3 based data lake. And that's really where the third part takes over. And when I demonstrate this, that's where the data is coming from. So again, you can see on the far left of the diagram, that's the GitOps process that I talked about. If everything succeeds, those resources are placed in an Amazon S3 bucket. They're made available to Airflow running on AWS with Amazon MWAA. And I'm going to be using those resources to do things like I'm going to query the AWS Glue data catalog. Based on that query, the results of that query, that data set, I'm going to write that into a set of staging tables in Amazon Redshift in my data warehouse. and then using a pretty well documented common methodology for merging data from a staging table into a permanent table in a data warehouse. And AWS has this process documented very similar to other data warehouses, and I've just codified that as Python in a DAG file. It will merge that data into the data warehouse. And that's a pretty typical task, loading data into a data warehouse. And then what we're going to do is unload that data. So the data is in the data warehouse. My data scientists, data analysts are able to interact with that and perform queries. At some point, though, I may want to unload the results of a particular query. So again, using Airflow, we run a fairly complex join across 5 different tables, do an aggregation, perform some different SQL-based computations on that data, and then we write the results out to another Amazon S3 bucket or another location in our bucket as Apache Parquet compressed in partition data. And then that data that's been written back to the data warehouse, right? So data can go into our data warehouse, it can come back out of our data warehouse into our data lake, and that's that lakehouse term that we use, right? So the data flowing in and out of the data warehouse and then in and out of our data lake. That data is now available again to our data scientists and data analysts, and they could use things like on AWS, that would be Amazon Athena, or they could use Presto or PrestoDB on EMR, or use any third party of our partners, Ahana.io, for example, any ad hoc query engine to be able to perform queries on the data that's been written back out to the data lake. And again, so all of that is going to be orchestrated by Airflow. And imagine if if you're a single developer and have a single analytics workflow, maybe all that automation doesn't make sense at first. Why go through all that heavy initial lift? But imagine if you have tens or hundreds or thousands of workflows, you need to schedule those. You need to schedule those on a monthly, a weekly, a daily, and hourly basis. You have different team members that need to schedule, or different teams that need to schedule. That's where using the DataOps principles, using automation, using tools like Apache Airflow on AWS or alternatives like step functions makes sense to be able to reproduce these processes on a regular scheduled basis and do them efficiently, and kind of remove the whole human error from that by codifying those processes. So that's what we're going to demonstrate in the demonstration today. So I'm going to jump into the demonstration. There's a few slides in part of the deck. If you miss anything in the demonstration, or if I get cut short here on time, there are some screen grabs of kind of what I'm running through. So first off, I'm going to switch over to, I happen to use a PyCharm, JetBrains PyCharm, or Visual Studio Code. In this case, this ticket-data-lake-demo, ticket data lake demo is the GitHub repository. I've just pulled that down. It's a public repository. And just very quickly, as you go through it, you'll see this .github. If you haven't worked with GitHub Actions, this is the kind of the structure of how you store your GitHub Actions. And then those are called on GitHub. So I have 2. One is the test tags. So when I do a pull request, or as an administrator, if I directly do a commit to the main branch, there's a series of tests that run, and we went through those in the diagram, so you can see that here. So this is the first action. If all those tests pass, there's another action, and you can see here, this will probably look familiar if you've worked on AWS with S3 bucket. So I have my S3 bucket, I have my access key, my secret key, and on GitHub, I'm able to create secrets out of all those. So I've created those secrets ahead of time, the name of the bucket, my access key, and my secret key. Those are stored securely in the project on GitHub in my private GitHub repo. And every time this particular action kicks off, it's able to pull those credentials in. And those credentials are tied to a role, and that role is limited to just being able to write resources to an S3 bucket. That's the only thing that it's able to do, is write from this repository to a particular location in an S3 bucket. We have Airflow variables, so we're able to store our Airflow variables in our repository and run tests on those. In the DAGs folder, so everything in the DAGs folder is what's getting written to our Amazon S3 bucket and is made available to manage Airflow. We have our DAGs, so I have, and you can notice my naming convention here, very specific naming convention. There's 6 DAGs that make up the second part in the series, which is building the data lake. And then there's a series of 6 DAGs, and number 6, there's a slight difference. So I have 2 versions of the 6th DAG, but these 6 DAGs make up the Redshift demo. So what I'll show you today, I'm going to be showing you these 6 directed acyclic graphs. Also in here, there's the SQL scripts that I mentioned. So we're working with Redshift, creating tables, writing data, copying data into our data warehouse, performing analytics on that data in our data warehouse, and then unloading that data. All of that SQL code that's been created to do that are all stored as SQL files, and those are also all part of my repository. So those are all available, and you can take a look at those. And I run tests on those to make sure that they fit my particular linting standards or code standards. Just a few other things, the Git hooks. So I mentioned, as a developer, as I do a commit, and I'll do a commit here really quickly as part of the demo, as I do a commit, I don't want to wait till the code gets to GitHub to find out that I have a problem and it failed. Now, it hasn't been deployed, so that's good, but I can shift that testing even further left by, if possible, running a subset of my test suite locally to make sure that my Python is written correctly, there's no errors in my Python code, my SQL code looks good, my configuration files don't have any validation errors. So I run all those ahead of time. And then if they pass, the push goes through. The requirements file, so Python, all the requirements files are here. The requirements file is also loaded into the S3 bucket and used by Airflow on the AWS platform. So you can define your requirements here if you want to load any additional packages into that. And then we have, lastly, the local test file. And this is the file that actually gets run by my pre-push hook. We'll run these tests locally. So we're able to run the same suite of tests locally, or a subset of those tests locally, that I'm going to be running on GitHub as part of the GitHub action. So I'll just do a simple change, and I'm just going to, a very simple change. I have one of the DAGs open here for my project, and I'm just going to change the description. So if you've seen a DAG before, it's written in Python. These are very brief. So although it sounds like, wow, these perform a lot of functionality, because of things like operators, and I won't go into too much into Airflow today, but using things like Python operators, bash operators, using the AWS specific operators, Glue, Redshift, the different AWS services, there's already operators for those. I have to write very minimal code. There's not a lot of boilerplate code. That's all been taken care of for me. So not a lot of code to write in order to perform this automation. So I've just done a simple change here to one of the DAGs. I've just changed the description, nothing that's going to break anything. And if I switch out to my terminal for a minute, and we'll just do a status check on this repository, you can see that this one DAG has been modified. So you might be used to using Git, and if it looks good, you do a Git commit and you push it to your main branch. I'm going to do that. I'm not going to go through the whole effort today of doing a pull request for the sake of time. So I'm just going to commit this. But even if, as an administrator, as an owner of the repo, if I want to do a commit, so let me add this in. And I'll just do a simple commit. So I'm just going to commit this to my repo. Just a simple update of the description. And note what will happen. That will not happen because I have a typo. Let's try that again. There we go. So the pre-commit, the Git hook does a pre-commit, and it actually checks my Python code and my SQL code. And in my case, and I've chosen to do this, it will actually rewrite the code for me if something doesn't, if it can fix the code, if it can modify that code or edit that code in order to meet my particular coding requirements, it will do that. And then as I do a push, so I'll push this to the GitHub repository, the public repository, the link that Chris shared with you. You'll see that it starts a series of tests. So again, linting tests using Flake 8, using Black, executing a series of unit tests using PyTest, and then using SQL Fluff. SQL Fluff will check dialect-specific versions of each one of my SQL scripts that the DAGs are calling. And then lastly, a very simple JSON validation test of the AWS configuration files. And obviously here, these aren't my configuration files. I've just put in default values for these. If you were using this repository, and you can go ahead and run the same demo, you just need to put your own values in for this. But again, it's checking to make sure that that's a valid JSON file before I import it into Airflow and lose all of my configuration. So that was updated. So all the tests passed, luckily. I'm just gonna break out of the demonstration for a minute. And let me go over to, get this out of the way. Slide that out of the way, sorry. I'm gonna go over to GitHub. So this is the public GitHub repo. You can see here, there was a number of pull requests that were done by a third party. So I have another GitHub account. I was able to do pull requests, make changes. Then as an administrator, I review those changes and I merge those code changes in, which then precipitated the GitHub action to move those into Airflow. We can see here the test is running. I'm not going to wait till this finishes for the sake of time. We're running a few minutes late. But you can see here that I ran those tests locally. It passed all the tests. I uploaded it. And imagine I'm one of several data engineers. So as one data engineer, I did some local changes. I tested, it looks good. I'm now uploading that. Other engineers are uploading their changes potentially. And then we're going to run a series of tests. So before as an administrator, before I even get a request to merge the pull request in or potentially merge the pull request in, I want to make sure that all the tests pass. And you've probably seen this before if you work with other open source projects. This is nothing new. So you can see here that all the tests passed. So I ran a full battery of tests on the Python code, the directed acyclic graphs. I ran a series of tests, dialog-specific SQL validation tests, and then I also just quickly validated that my JSON was valid for my configuration. All of that passed. So the second GitHub action then also ran, which is the sync DAGs. You can see that that's running right now. And this is now taking all of the resources, the DAG files, the SQL files, and you can see that they're being uploaded. So they're being uploaded, they're uploaded into an S3 bucket. And now they're all available. So within about 60 to 90 seconds, if you're familiar with working with managed Airflow on AWS, it takes about 60 to 90 seconds. These files will now be available to me in Airflow. So if I've made a change to a particular DAG file and I now want to run that, that will be available to me automatically. All I had to do was commit that code or make a pull request. And then, however many minutes later, now that code, assuming everything is passed and that code is correct, it's available to me. So I'm going to switch over just to finish up the demonstration here. So I'm logged into AWS. I have a single Airflow environment, and obviously working with customers, depending on the size of your organization, you may have multiple Airflow environments. Maybe you have a dev, test, and a production Airflow environment. You might also have Airflow environments spread out across different geographic regions, or you might divide your Airflow environments up across different accounts to separate dev and test, let's say, from production for security reasons. So I just have a single environment, and I've gone ahead and opened the Airflow UI. And although this is a managed version of Airflow, once you're in the Airflow UI, it is Apache Airflow, right? If you've used Apache Airflow before, this should look no different to you, whether you're using it, if it's self-hosted, if you're running it on AWS, if you're running it on Azure or GCP or anywhere else. This is Apache Airflow. So now in the UI, I could also make changes to this programmatically through the CLI using the APIs. For the demonstration, I'll just stick to the UI. And you can see here, so I mentioned the 6 directed acyclic graphs or DAG files, which are part of the demonstration for loading and unloading data out of our data warehouse. You also see those here. So those exist in GitHub. They were synced to an S3 bucket, which now makes them available in the UI. And we're able to go into any one of those files and we can take a look at those. Again, if you're not familiar with Airflow, this is the tree view. So you see the different tasks. And if you're not familiar with DAGs, a DAG is a series of tasks. So each DAG has one or more tasks associated with it, independent pieces of work. We also have the graph view, which is maybe a little more friendly. And you can see here, we see the begin. So I've just added a dummy tag. It's a little easier to explain it, I think, to explain it and understand it. It begins, it then branches out or fans out. So for each of the 7 tables, I'm in this case, I'm dropping a table, I'm creating a table, I'm loading data into that table. Maybe I'm moving data from a staging table to a permanent table. And I'm able to do that in parallel, right? Since in this case, those 7 tables in this demonstration are not dependent on one another. That means that I can do things in a sequential fashion, or I can do things concurrently, depending on the action. So in this case, this DAG begins, and then it runs 7 concurrent tasks. So in this case, it drops those tables. Again, it could be loading data into those tables or creating those tables. And then once that's data done, it does a quality check to make sure that those 7 tables do in fact exist. We can also run our DAG. So I'll just, what is referred to as trigger that DAG. If you have any additional configuration, if this particular run of the DAG is specific to a specific environment or a workflow, I can inject additional configuration into it. In this case, I don't have that. And we can go ahead and trigger that DAG, and that DAG will start. And I'll go back to the graph view, and you can see that begin is now green. And eventually you can see the 7 concurrent tasks are now green, which means they executed successfully. The create table test was created successfully, and it ended successfully. So that run of that DAG was successful that I triggered. And if we go back out to that, we can see here that we can also see our number of successful runs. Just a few other things, and I'll finish the demo here in about 2 minutes. Things like variables, I won't actually call it my variables because I'm actually in mine, and it'll probably disclose some things I don't want to, but any type of variable, the name of a bucket, the URL of a particular maybe API that you want to hit to pull some information back, the name of your Slack application channel that you want to send notifications to, anything like that is a variable that you can configure in here. You also have connections. So in this case, the only connection that's really relevant for this demo is I have an Amazon Redshift data warehouse instance set up, and I have the connection type. So I'm using a Postgres connector to connect to that, and I have the URL in there. So you're able to configure all of your connections, and those don't necessarily have to be a database, but anything that you would normally connect to, you can securely store the credentials for that in Airflow. And then last thing here, and I'll finish up and turn this back over to Chris. So I mentioned that a DAG is a series of tasks, and as you execute a DAG, it executes a series of tasks and sequentially or concurrently. The other thing that you can do, and the last DAG in the demo runs that, and I'll go to the graph view for a minute. You can also, just like you would do in DevOps, right? If you worked in DevOps, you have pipelines. One pipeline, as one pipeline finishes, it might trigger another pipeline. So you can execute pipelines sequentially or concurrently. You can also do that with DAGs in Airflow. And again, this isn't specific to AWS. This is built-in functionality in Airflow. I have those 5 DAGs that make up my workflow, right? So checking the quality of the data, copying the data into my staging tables, merging the data from my staging tables into my permanent tables, and then later on unloading the data from my data warehouse, and then performing some analytics or some queries on that data and writing that back to my data warehouse. So that's kind of what those 5 DAGs do. And I can run those sequentially. So imagine every night at midnight, you get a batch feed in of data. And in the morning, you want to make that fresh data available for your data scientist, your data analyst. So the data comes in at midnight. I would schedule this task to run, let's say at 2 a.m. It would run all 5 DAGs, each of those DAGs containing multiple tasks. It would end. It would send me a Slack notification if it failed. It might send me one if it succeeded. And then when your team comes in the morning, they have fresh data available. So that's a very simplistic workflow, but that's kind of what you're able to automate using the GitOps process to make sure that what you're putting in your analytics platform is of the highest quality, and then using tools like Airflow to automate that and make that very repetitive, very efficient, very cost efficient, and eliminate any human errors from a high volume of analytics processes on the AWS platform or any other platform. Chris, I'll stop sharing and end it there. That's all right?
Sure. We've got a couple questions. I asked one up above about iceberg format. Yeah, what do you know about the iceberg format, the Apache Iceberg?
Yeah, so it's a great question. So I work with a number of customers, and there's obviously AWS has also adopted, we have our own governed tables that we're coming out with. We have integrations with Apache Hudi, and most recently, I think we just announced one with Iceberg, but certainly I see a lot of customers adopting Apache Hudi, probably most prominently Delta Lake or Delta Table, the open source version from Databricks, or Apache Iceberg, all 3 of those being popular. I'll call them data lake formats, table formats, is a way to manage changes in your data lake, right? So as you have changes coming in from your data sources, how do you maintain the current state of those changes? There's other features, but that's primarily what I see customers most interested in, is keeping parity with their data sources in their data lake. But yes, all of those could be incorporated. Again, this demo was meant to be very independent of any particular technology.
Cool. Another question from Wilbur asks, can you make access to those variables secure?
Yeah, so if you're familiar with Airflow, there are ways to secure access, to give fine-grained access control on AWS. That's also done through IAM. For some finer grain access, I've seen customers, and that's why you might use multiple environments, multiple instances of Airflow. Maybe it's one per team or one per dev, test, prod environment, or using separate accounts. I've seen a few different techniques. It's not as easy. I've seen a combination of those tools used to kind of isolate and protect those variables. I think though, having those, obviously I'm using a private GitHub repo. I haven't exposed anything, but I'm confident that those can be stored securely. I do have a couple customers that are looking for a little bit more encryption, so they would like to see more use of things like Secret Manager to store secrets and not have those in plain text. And that's true of Airflow. It's true of things like Apache Kafka, Kafka Connect. I have that different customers that are concerned about some of that configuration exposing credentials.
Cool. Great session so far. So George, how are any issues in the DAG handled? What about notifications, the ability to roll back to a previous checkpoint?
Yep. So I mean, that ideally is one of the advantages of using a GitOps workflow, right? So everything is in source control. I'm able, if something did go wrong, I should be able to roll back to a previous commit or roll back a merge. I would then recommit that change, and that change should then automatically be synced, assuming it all passes, and it will overwrite I'll just use specifically, let's say the DAGs. Those DAGs would be overwritten in Airflow. Again, it's just syncing to an S3 bucket, so I would overwrite those. But again, you should have that total commit history in GitHub or GitLabs or whatever Git-like product you're using. You should be able to roll back. So that's great question. I would say that's one of the main advantages of. And then just quickly, notifications, that's part of the demo. I use Slack. There is a module, again, it's Python. You can use any Python construct when you're doing development. I have a separate module that uses SNS or Slack. So depending on what my use case is, but most often I kind of use Slack Ops for that.
There is a way with Airflow to catch these exceptions and trigger retries, right? And that's
Yes.
kind of the whole bread and butter.
Yes. Yeah. And I probably touched on 1% of Airflow is an amazing product, ton of capabilities in Airflow, and they're all available again. Even though I'm using Manage Airflow on AWS, there's really very few limitations to what that means, other than it's managed and some things are locked down, but the majority, 98% of the functionality of Airflow is available for end users.
And there's Airflow operators for most of the AWS data sources, or even all of them, right? I mean, S3 obviously. Are there ways to get to like Dynamo and like RDS and that as well?
Yeah, let me just quickly share my screen once more. Sorry. If you go to the Airflow documentation, one thing I forgot to mention, I'll just mention that as we go to operators. Airflow right now, at least on AWS, and I'm sure for folks that have used managed, see if I can get out here to the operators. It's in the Airflow documentation. Let's see, Airflow, AWS operators. One thing to be careful of. So on AWS, you can see those here. Currently, and obviously you can see here 2.6.0 of Airflow. I think Airflow itself is like 2.23 maybe. The version that I'm using is 2.02. That's the one that's available on AWS. And the one thing to be careful of, especially with Python, is making sure you're using, as you're doing your local testing and local development, that you're using the same libraries and modules that are preloaded with, in this case, MWAA, or that you're purposely using newer ones and you're making those available to Airflow. The biggest problem I get myself into is using something that's not available. So I think there's a Redshift operator, for example, the Redshift SQL operator. I believe that's only available in a version later than the current version that's available through MWAA. So you just have to keep those things in mind. And that's true of any, I think, managed service from any of the platform providers are usually at least N-1 or N-2. And you want to make sure that you have parity as you're doing development. But these are the operators. So I use the Amazon Athena operator, I think, in the code that's available. A lot of customers, they're doing most of their compute, right? So Airflow is not a computation platform. You don't want to actually be doing ETL with Airflow. You want to pass that off. Oftentimes, customers will use service-specific operators, or generally they'll use ECS or EKS, and you can obviously pass tasks off to a container or pod running on EKS, or a task or a job running on ECS. But these are all available ones. The only thing I would say is make sure that you're viewing the ones that are actually available for. You can see there's a slight difference there. So 2.02 is a version that's currently available on AWS. So a few less. You'll notice, like example, that Redshift operator isn't necessarily available.
Yeah, so I remember we got burned during the book writing process with the versions, because there was major changes between 1.0, like Airflow, and then 2.0, and then it seems to be even more changes coming throughout the 2.x. So great tip.
Yes.
Okay, and I guess kind of a general question, what's the best way to learn all of this end to end? DAGs, Airflow, yeah, like MWA.
Yeah, totally my personal opinion. I love Astronomer. So, I love the open source community. Astronomer they offer a managed version of Airflow, but I think Astronomer in particular has a phenomenal set of documentation, like that testing strategy that I used. A lot of that came from Astronomer. They also have weekly webinars, and I don't work for Astronomer, but you asked me an honest question. Their webinars are very good too. They just actually ran an excellent one on testing DAGs, not necessarily automating it, right? But how do I test a DAG? They really go into depth in that. I barely scratch the surface, but yeah, I like Astronomer for Airflow specifically.
Gotcha. Yeah, pretty well-funded startup. Also has a lot of customers here. It looks like Marriott, Sonos, NBC. So
Airflow Summit's coming up, I think, in May. The Airflow Summit, all of those are all on YouTube. There's some great videos on YouTube from, again, a lot of those customers you mentioned that are really digging into how they use Airflow at scale.
Airflow Summit. Wow. Okay, sweet. Also, final question. Yeah, have you heard people call MWAA moi, like a kiss? Like
I have not. I have to be honest. Of all the acronyms on AWS, that it's my favorite. One of my favorite services. Right. I think it's my least favorite acronym. I just say managed Airflow.
Yeah,
I call it managed Airflow. Yeah.
Yeah, and I think
MWA just doesn't roll off the tongue.
I know.
Sounds
right. Yeah, and then Kafka, yeah, that one always confuses me. Was it managed streaming for Apache Kafka, but they don't put the A in there. It's just MSK. And it's
MSK. Yeah, MSK, that's okay, but the MWA, just too many letters for me.
Awesome, buddy. Okay, let me flip over. I'm gonna grab the screen here. We will likely go over a bit because I do want to get through all the slides. Yeah, Gary, feel free to drop off if there's no more questions. Can we have a link to download the video? Yeah, I'll be posting the link to this specific event here. That's the Meetup page. I've already posted the link to Gary's talk and to his GitHub repo on there, and I will add another comment. So let me grab the screen. Okay. And participants can see my screen, so I think we're okay. So yeah, I'll put it here. Antje, if you can man the chat for a bit.
Will do.
And let me find my talk here. I'm kind of creating it while Gary was chatting. So let me make sure I can, let's see, how do I always do this here? Presenter view. Antje, can you see the main screen?
Yes, I can see your slide.
Okay. So just a reminder, today is the celebration of Martin Luther King Jr., born January 15th, 1929 in Atlanta, Georgia, here in the good old US of A. There's a picture of him. I actually couldn't find what year that was. I yes, I love this picture, except for that cup. If you're like me and you're a little bit OCD and you tend to drop cups and bump into things, I'm about to bump into my water cup here. That cup always bugged me because it looks like it's gonna fall. But very powerful picture. And the main link, by the way, for all of these resources, including these meetups and the book, is datascienceonaws.com. So quick reminder, Antje and I did write this book during the pandemic. We released it middle of last year sometime. It's still very much up to date, even with Reinvent. I will talk about some of the new features and new launches at Reinvent, and that's what we're going to cover here. So thanks everyone for joining on this day off of work. Speaking of Georgia, something that happened just, I think, last week was the Georgia Bulldogs. This is US college football, which you may or may not be familiar with, but, and this is the American football, of course. Georgia Bulldogs actually defeated the Alabama Roll Tide, so 33-18. This was kind of an upset. So, but speaking of Atlanta, Georgia, and Georgia in general, here is the agenda. We're going to talk about the latest in the application development, serverless compute, networking, architecture, storage, databases, AI, ML, and then analytics. Now, this is a lot of topics here. Was this 5, 9 topics? But I just have a couple kind of best of slides for each one. So this should go fairly quickly. Also, one quick teaser here, Antje, if you want to post this link, I know this was your project. You spent quite a bit of time. Do you want to actually talk about this real quick, Antje?
Yes, will do. So, folks, we do have a hackathon running right now. It's called the AWS Disaster Response Hackathon. We launched it at Reinvent together with a new service that Chris will show you here in a bit, Amazon SageMaker Studio Lab, a free, no charge service you can go to, sign up, no credit card required, no AWS account required, to get a Jupyter notebook and run your ML code. And together with Studio Lab, we launched this hackathon here. It's still open. It's running through February 7th. So you can still sign up, join there, and then use SageMaker Studio Lab and build a powerful application, a great idea, whatever you come up with, to help improve disaster response. We do have a couple of videos there. We're working with disaster relief organizations globally. They posted short videos describing their challenges, their problems we think can be solved with machine learning. So it's a really cool hackathon. You can apply computer vision, you can apply NLP, whatever you're feeling familiar with, and then come up with hopefully creative ideas to help solve some of those challenges. And you can also win something. So we do have 54,000 USD in total prizes available. And as a fun fact, we're also trying to set the Guinness World Record for the largest ML competition. So if you do have some spare time over the next weeks, feel free to sign up. I posted the link here in the chat.
Great. And we are working with our trusted partner DevPost on this as well. They host a number of the AWS hackathons. Very, very cool company, very fun to work with. So thanks for the DevPost folks. And quick reminder, this is February 7th is the deadline. Is that the absolute last date, Antje, for folks to submit a model?
Yes, this is the deadline to submit the project that includes an ML model. It's 3 weeks out, yeah.
And does it have to be a model, or can it be a visualization?
Yeah, it should contain a model. You don't have to build a machine learning model from scratch. You can use one of the existing ones and then just fine tune it, adapt it to your specific use case you're building, your data set you're using, etc.
And there are data sets available that people can link to off of this link. Is that correct?
Yes, we do have a resource page that shows a lot of sample data sets you can use, and you're obviously also free to, if you know of some local data sets around your specific geo that could help, you can also definitely use them as long as they're public.
Yeah, it's a pretty free form hackathon, right? So people can get creative as to how they actually want to
definitely
solve
yes
their problem. Okay. And yeah, so submit soon so that you can become part of this Guinness World Record. That'd be a fun little fact for the family. Okay, let's get into, oh, I thought there was one more thing I was gonna say. Oh, the other cool thing, so Studio Lab gives you free GPUs, and I'm gonna show you this in a few slides, but if you sign up for Studio Lab, which again does not require any credit card, similar to the Google Colab, if you've ever used Colab, you can actually migrate your projects over to Studio Lab and you get free GPUs, which is super exciting. Free GPUs would definitely get me to sign up. All right, let's get into the whirlwind here. I'm going to mention a lot of product names and service names and feature names. You likely will not know, maybe 50% of these or, 20% of these, depending on how familiar you are with the AWS product line. But these were the, I'd say top, 50, 60 slides that I found interesting, top releases. I think the full spectrum there, might have been hundreds of new releases, maybe, actually don't know the number, but these are the ones that I found pretty interesting. If you've ever heard of something called Amplify, this is a very, very large open source project, very popular open source project. Actually, a few of my direct coworkers have actually moved on to this team, the Amplify team. And it's a low code, kind of no code, well, I'd say low code way to build apps. And you can integrate with data sources, you can drag and drop UI things. And so that's now part of what's called the Amplify Studio. So what they did was they took an open source project that they built within AWS and have now made it this nice fancy UI so that you could build feature rich apps. And having run startups in the past, this is a huge time saver if you can actually, I guess would say automate or factor out, all of this UI code and just, very simply create it through something like this Studio. This will save you a whole lot of development time and let you focus on your actual, startup business or your actual enterprise business. CloudWatch, real-time user monitoring, RUM. This is another fun acronym here. So I actually haven't had a chance to integrate this, but what this reminds me of course, is Google Analytics and the ability to sort of break down by browser, user journey, slowest browser by page load. So things that you would typically see within Google Analytics, we're now seeing as part of CloudWatch. And so this is really cool because we can now take the end user experience and merge it into the monitoring with our backend. So there's monitoring now at both the UI layer that's now integrated into CloudWatch, which is traditionally used on the backends. And so there's just a little snippet of JavaScript code that you add similar to Google Analytics. There's this service also now called CloudWatch, and then I guess this is Evidently is what they have decided on for the project. I actually didn't know anything about this project until it was launched. This is awesome. This is the ability to do feature flags. And if you've ever built any applications and wanted to slowly roll out features or even disable features for the basic edition of your SaaS and the enterprise edition, you want to turn on and off certain features. So this gives you the ability to actually do what's called dark launches, where you can launch and just give certain features to a small segment of your user base. And so this reminds me, there's a company called Dark Launchly, I believe, that focuses on feature flags. So pretty cool use case here if you're into. And so this integrates with App Config and Systems Manager and some other services that you may or may not know. And there's 9 programming languages supported as of right now, and those continue to expand. If you are familiar with the actual low-level AWS software development kit, you know that there's Java bindings, there's Python bindings, Ruby, C++, .NET. These have all existed forever, Node.js, JavaScript. There's now 3 new implementations here, and that's going to be Swift, Kotlin, and Rust. So for all you Rust heads out there, you can now use Rust to interact with the AWS API. So here's another really cool project. This is open source, was created by AWS, and this actually relates to Kubernetes. Now, this tackles the problem of scaling your EC2 instances or the actual EKS, right, like infrastructure, scaling it out and scaling it back in as more demand comes online for your application. So I'm not going to get too much into this, but for those of you into EKS or like Kubernetes, this is open source, and this does really help out. So the term in the Kubernetes world is cluster autoscaler, or CA. And so this will actually take a look and see that there's a number of pods that need to be scheduled. There's not enough capacity, so they're going to, so this Carpenter project will launch more nodes and give you that extra capacity just for the time that you need it, and then it could scale back down. So think of it like cluster auto scaling for EKS. So pretty cool. There's also now public ECR repos, and this drove me nuts at my previous startup and the first couple of years I've been here at like AWS is, I want to post my Docker containers to the community, and up until now, we only had private ECR repos, and so it was very difficult. So I was forced to put things onto Docker Hub or like an S3 bucket somewhere. It was really wonky. Now we offer public repos. So if you have been using Docker Hub, you can now switch to use these public ECR repos. Pretty cool. There's also this marketplace. So now back into Kubernetes land, also like ECS as well. So there's ways now to deploy or to sell or just like offer for free your like containers to run anywhere, to run on like EKS, which is the Elastic Kubernetes service, which is managed Kubernetes, or can run in your self-hosted. So a nice little marketplace here, similar to at the like very basic would be like the Amazon.com marketplace, where we have vendors offering products. We have various different marketplaces within AWS, and now this is available for these containers. All right, this is actually one of my favorite launches here, which is called Repost. And this was a pretty huge project internally. This really, as far as like I can tell, this kind of replaces the forums, or it's now being preferred over the like AWS forums. There's a lot better ways to engage and to get your questions answered. So this is called Repost. And one of the big projects that we had on the like machine learning side was taking our internal question answer and making those answers public. And so we had to strip out some like customer things that were in there that were specific to customers or any sensitive information, but all of those filtered answers have now been posted publicly. And so this is a like great place to go out and ask questions across all the different domains, including analytics and serverless and machine learning. Let's jump into serverless. Pretty cool feature here now that you can filter these messages or these events. So like Lambda is our serverless, our sort of marquee serverless function as a service, if you will. There's ways to filter messages that maybe your Lambda shouldn't be handling or not relevant to. And so before, you had to actually call the Lambda, then filter it and sort of throw it away or send it somewhere else. Well, now we could filter before the Lambda call and therefore save money and route it like accordingly. So if you're not really familiar with the like use case here, it's probably because you haven't had this issue, but for those people that have had this issue, this definitely helps to reduce costs because you're not actually invoking that Lambda and then filtering. You can filter before and much cheaper. Ephemeral storage for Lambda. This is huge. A lot of customers have been asking for this. You can now actually get up to 10 gig so from 512 megabytes up to 10 gig, which is pretty nice. And that's the temp directory. And you can put, basically like, yes, anything in there. So typically people put, zip files or libraries or like models, right? And so I'll talk a little bit later about how we can now serve our model predictions with Lambda, which was a huge ask by customers. It's called serverless inference. And this really gives you a way now to load in pretty large models onto the storage here. And storage is encrypted as well with the managed keys. Yeah, so Antje, yeah, are there any questions I should like address before I keep going? I see a couple messages in here.
I think we're good for now.
Okay. Step functions. These are now part of the Athena console. So the Athena, this is our basically managed Presto with a few extra like integrations into AWS. And here we can actually build step function workflows from the console of like this service called the Athena service. And so we can actually view the interactive diagrams. And so, Gary was just showing you how to do it with like Airflow. You can also build these pipelines using step functions. You can build them using SageMaker pipelines. Lots of different options depending on what your particular enterprise is either whitelisted for or has committed to. And so, yeah, you can actually launch sample projects and querying large data sets, and this will actually like generate those workflows, and you can monitor them from here as well. Let's jump to compute. So yeah, so I have to be perfectly honest, I personally don't quite understand why the M1 Mac instances are so popular, but this was huge during Reinvent. I never developed, I use my Mac, but I don't really find myself needing to actually emulate or to spin up a virtual EC2 instance with this profile. Those of you that do Mac development probably find this awesome, but I'm throwing it in here, even though I didn't particularly find this that useful. All the other people I talked to seem to be totally amazed by this. Yes, even Antje loves this. Yes, Antje, why do you love this? What kind of Mac development do you do?
Yeah,
it's
might
just
be
cool
starting doing some now, right?
True. Yeah, I don't want to actually develop on my Mac because it might mess up my Mac because I'm not, very good Mac programmer. So maybe the ability to spin it up here and build a Mac OS application would be kind of cool. Okay. So right, here's some more specs on this M1 Mac. So it's using the new Apple Silicon. But in addition to the Apple Silicon, right, which is the M1 chip, we have integrated it with the Nitro system, which is something by AWS proprietary that offloads things like security, things like networking. So when you see the word Nitro, this is the type of instance that you want to start using from this point on. And so Nitro is not new. And at Reinvent, there were probably 4 or 5 Nitro talks, at least 1 or 2 deep dives into why Nitro, where did Nitro come from? This really is meant to give customers the full CPU, the full compute power of the silicon that you've chosen, whether it's AMD, whether it's Intel, whether it's the NVIDIA GPUs, or now the Apple M1 Mac. And so instead of the actual M1 chip, right, like having to do security and having to do network IO and be thrashing back and forth with all these different low-level like hardware details, we can now offload this to Nitro and give more of the chip to the customer, which is really, really cool. So keep an eye on that. This really helps to right, like reduce latencies and variances, and keeps hardware specific to security and then hardware specific to the network. And all 3 of these systems can now operate at full speed. Okay, so there's some options there. Also, some new compute options, Graviton 3, and then we have a new C7G instance. And so, here's some specs here, 25% better performance compared to Graviton 2. Graviton, this is the AMD offering. And this is the first in the cloud to offer DDR5 memory, which is pretty cool, 60% more energy efficient. And what we're starting to see now, and I haven't gotten to the slide yet, but one of the new pillars of like AWS is now sustainability. So we used to have, I think, 5 pillars. Now we have 6 pillars. And that 6th one is sustainability. So, trying to build more of these energy efficient chips. Okay, so C7G, that's the latest there. There's also IM4GN and IS4Gen, and these are more for the storage intensive workloads. So this is what you would want to be using maybe for your Spark workloads, EMR workloads, and so a bunch more options here. These are all using the Nitro SSDs. And so that's the other part too. So there's networking for Nitro, there's security for Nitro, and then there's the Nitro SSD, which is offloading the controller to the Nitro subsystem. Super high performance. We'll see there is a new instance type that offers, I think I haven't gotten to it yet. Let me see where it comes in. 800, there's an 800 megabit networking. I'll get to it here in a bit. Before that, let's talk about Compute Optimizer. Now, the cool thing here is you can point to your current workload that's running. And we now have this service called Compute Optimizer that will tell you whether or not you are running the right workload on this type of like instance. This also, by the way, now includes Lambda. And so all you have to do is just sort of opt into this and point it to your workloads. And there's the screen that says, hey, you are completely underutilizing this particular workload. Why don't you switch to a cheaper instance or try to optimize the workload to take more advantage? Maybe you are only running at 30% of your CPU load, or and so now you might want to actually change those instance types. So yeah, pretty cool stuff. It's basically free money. If you get this thing pointing to your workloads, you can like very quickly figure out where you can save money or improve your performance. And once again, this does include Lambda. This will help you what's called right size your compute workloads and tell you what you could be doing differently. CloudWatch Metrics Insight. So this is pretty cool. This isn't obvious what it is at first, or at least this wasn't to me, but this lets you now run SQL on real-time CloudWatch metrics. And so CloudWatch is both metrics and logs. Here, I think we're specifically talking about the actual metrics, and you can identify trends and figure out in time series manner, what's happening both historically and then predictive as well. So you can create cool visualizations, create dashboards, on-the-fly metric aggregation, really cool stuff. This is things that you would typically have to do on your own before this service was launched, or this feature of the CloudWatch service was launched. And there's a nice visual editor also. You can use this for both EC2. You could use it for hybrid, so on-prem also, if you're pushing metrics from your on-prem like data centers into CloudWatch, this will operate on those as well. Okay, so the Amazon Bracket, this is our quantum service, now supports what's called hybrid jobs. And this really is where we're at in the sort of quantum lifecycle. It's called the NISQ era, or noisy intermediate, oh man, I can't even think now what NISQ stands for, but yeah, it's NISQ. Where we're at here is we are treating the quantum computer as though it's a GPU, right? So these are called QPUs. And with AWS, you can actually use hardware that's offered by partners that that are focused on quantum and building quantum processing units. And so what's happening here is we're going to use traditional machine learning And think of it like hyperparameter tuning is sort of happening within the CPUs and GPUs, but if we want the QPU to actually run the quantum part of this algorithm, and then that feeds back into the CPUs, GPUs to do the rest of it. So we see hybrid algorithms that really is the best way to utilize this quantum hardware right now, given the state that we're in. Okay, so yes, using combination of EC2 with quantum hardware. You can also, by the way, use simulators, which is much, much cheaper than trying to use the actual quantum processors from our partners. So check that out too if you want to get your feet wet or hands dirty or whatever term. If you want to get experience with Bracket, you can use those simulators. Outposts. This is, I was trying to get a hold of one of these. They're, I think the cheapest one's like 100 grand. I've got a lot of other things to do with 100 grand. So I had to convince myself not to do it, but we do now have cheaper versions. So you can actually get a single server to put in your rack. You can get a 2U single server or get the full 42U full rack if you have room in your house, if you have the power, the cooling, all that other stuff. But I think this cheapest one, the last I checked, was 100 grand. So Outpost, if you're not familiar, just kind of backing up, gives you the ability to run these like AWS services in your data center. So it's a lockdown box. I don't think you can break into it and steal anything. I don't know if anyone's actually tried to do that, but I assume that they're very locked down. What happens here is, yes, AWS runs these services and still manages these services, but those services are running in your data center, okay? And it's not all of the services, but it's all of the sort of early ones like EC2 and S3, so ECS, I believe EKS maybe at some point. That I probably shouldn't say it if I don't know it, but you can run IoT Greengrass in your data center, but it's still managed. And so what happens here is you like fire these things up and you can now access them just like their own availability zone or, okay. And so they start showing up as an option when you're going to run your like EC2 workloads, for example. So we've expanded Outposts to multiple regions here: Costa Rica, Ecuador, Morocco, Nigeria, and Vietnam. And yeah, Antje, didn't you live in Costa Rica? Where do you think this would be? Which town do you think that would be?
Yeah, that's a good guess. So I lived in the capital in also called San Jose in Costa Rica.
Oh, there's a San Jose, Costa Rica. Wow.
Yep. A lot of people get confused with the airport codes and end up in the wrong country.
Yeah. And Nigeria, and then Vietnam. So a lot of these outposts coming online. Speaking of outposts, we have also extended local zones. And so local zones, the implementation here, I believe, is Outposts, which is, I think, public. Yes, if not, it is public now. Think of a local zone as a single AZ sort of mini region. But they're not regions. They actually become a zone within a region that is close by. And so this is a little bit confusing, but so here's like Northern California, and here's Oregon, and so up here in like the upper left, and then below is Los Angeles. And so yeah, with like Los Angeles, for example, it wasn't big enough to create a separate region because we already have a region, which is US West 1 and 2. 1 is Northern California, 2 is Oregon. So there wasn't like enough customer demand to build out a full region, but we still wanted to put right, like enough compute down there, maybe 1 or 2 data centers that would then be considered what's now called local zones. And so all of our media customers, gaming customers that didn't want to take that like latency hit going up to Northern California, up to San Francisco, which is, I don't know, 800, 900 miles, something like that. They can now deploy their resources inside of this local zone, and which is a set of these outposts essentially that are all managed by AWS. And so you would just opt into the nearest local zone that's near you. Just know that these are not full regions. And so if you want, full, right, like the, like fault tolerance, you want to then peer this with these other zones that are in those regions, okay? Networking, Cloud WAN, this is really cool. Cloud WAN, if you've ever managed your own networking within the cloud, there's a lot of moving pieces. There's a lot of things to know about. There's transit gateways. There's site-to-site VPNs. You've got private VPCs. You've got you have subnets that are public and private. You have load balancers. All this kind of stuff going on. This can get really hairy. There's now a single point of control or single pane of glass into your network, right? And so this really comes from customers asking, hey, how do we actually manage these things and see one central dashboard where all of our of these like networking bits all live, okay? And also partners can also hook into this, what's now called Cloud WAN service, okay? And so this lets us see all of our segments, any VPNs that are set up, direct connect, all these things happening. So pretty cool stuff. I actually got this working and it finally made sense of this pretty complex like service app that I've been working on with SAS and machine learning. I was able to actually visualize my tenants, see where they were, see how they were connected. There's one other cool feature here now too, which is called the IP address manager. And if you've ever set up your subnets within VPCs and like sort of gotten lost as to where you are, or no real central record of what you currently have allocated. So this is now a feature of the VPC service that will let you actually manage your IP addresses. So pretty cool stuff. I should mention too, this actually isn't in this deck, I don't think, but there were quite a few IPv6 announcements. You can have now a VPC that is IPv6 only, and if you then need to peer with other IPv4, you then have these gateways and these translators, these IPv4 NAT translators, or what would be IPv6 to IPv4 translators. So check that out if you are interested in IPv6. A whole ton of new announcements. They spent quite a lot of time getting support for IPv6 out there, which is great. And network access analyzer. This thing has saved me now so many times. So like I said, I've been working on this project that has multi-tenant, and I want to make sure that my tenants can never see each other. And while I have all of the security groups and the Kubernetes network policies in place, I want to always be checking and making sure that those tenants can never talk to each other. And this is pretty cool here. So this will actually let you look at the scope of your network interfaces. This will help you reason through which like internet gateways can get to which private subnets, and constantly show you. So yeah, you can see in the sort of bottom right part where it says path details. This will show you from a specific like internet gateway, which would be public, what can it access on the inside, and really help you make sense of the actual connectivity between all of your pieces. So yeah, this is used as part of security reviews. Can also actually be like integrated with your CI/CD. Maybe you want to do a quick check on the network access before deploying a sensitive application, so you can have it all integrated. This is all like available through APIs as well too, and nice cool visualizations there to show you what can talk to what. Private 5G. I think this is cool enough that it made it into this deck. I personally don't see myself spinning up a private 5G network anytime soon. But if you have the resources to do this, you can actually spin up your own 5G, and you can hook up thousands of devices. I think the target audience here is schools or campuses or corporate campuses, but this gives you pretty much everything you need: the servers, the cell radio units, to build your own 5G network. So not particularly useful for my day-to-day, but maybe someone out there wants to pick that up. Data out, transfer price reduction. I love including price reduction things here. It earns trust with our customers. It makes me feel good about working here. So transfer out. Like getting data in to AWS has always been free. Getting data out is where you have to be, cautious about how much data movement is happening. And yes, in particular, cross regions. If you go from one region, if you're transferring a bunch of data to a second region, if you're doing backups, or cross region, synchronizing your like RDS database or DynamoDB database, you have to be careful of the what's called data out transfer prices. And so we've got price reductions here. This actually started December 1st, 2021, and this is perpetual. So not a short-term thing. Also, the free tier has been bumped up. And so free tier, for example, for like EC2, and this is data transfer going out, you now get 100 gigabytes of data transfer out for free per month. Okay, and so if you're always trying to ride those free tier, which if you're starting out, that's probably what you want to do, keep your expenses down, you now have, I believe, 10x more. So I think it used to be 10 gigs per month, now it's 100 gig. If you're using CloudFront to front your application or front your data transfers, to use the CloudFront sort of global network, CDN, content delivery network, the free tier has also been bumped up also. So you got 1 terabyte of data transfer. This is super helpful if you want to get closer to your end user. All right, and I think we are over time by quite a bit here. Yeah, Antje, we're about 30 minutes over, right? So let me get to this. I'm just gonna.
Yeah, maybe focus on the remaining highlights. Okay.
So there's now this instant access tier for Glacier. So this is cold storage that you can now pull certain pieces of data that are stored in Glacier, pull them back within milliseconds. So check that out. That was always a big limitation with Glacier. S3 price reduction. So 31%. Storage price reduction, right? Like again, as like AWS scales out, we are now able to offer cheaper prices. We pass that on to the customer. EBS snapshot. There is now a like archive option for your snapshots. Yes, EBS is the elastic block storage. That's often used by EC2 instances as sort of network attached storage. You can now put them into archive mode and get huge savings. With that comes a new feature called the recycle bin for these EBS snapshots. So just in case you do delete, you now have a period of time when you can recover. Also, if you've ever done any, sort of massive job training, and with your like machine learning workloads, you might have been using what's called the Amazon FSx for Lustre file system. And so this gives you very, very high throughput, so yeah, this is where we can get 400 gigabit per second on these EC2 instances. Think of it like a caching layer on top of like S3. So now there's like automatic S3 integration. Before you had to kind of manually set it up. It was a little bit wonky. And so this is now becoming much easier. So if you've ever used something like the Databricks file system, if you've done like Databricks, they have this sort of metadata caching layer or a full data caching layer that can actually cache the data and speed up your like analytics workloads, your machine workloads. That's how I think of this FSX for Lustre file system. It is a distributed file system, so you can scale it out to large training jobs. Here's that new pillar. So cost optimization, performance, reliability, security, operational excellence. Those were the 5 pillars for many, many years. Since the beginning of AWS time, there's now sustainability. So all of our pillar charts now have to change, and we add sustainability, which is really cool. This I find pretty cool. This is what's called these lenses for well-architected. And so this term well-architected is really best practices to and sort of prescriptive templates, if you will, and on how to actually architect your systems in the like AWS cloud. And these can be specific to industries or tech domains, so gaming, machine learning, SAP. If you're trying to do and like keep an eye on governance, you can start with these what's called lenses and then start to adapt them to your needs. Okay, a couple slides on analytics. And so Gary was speaking about data lakes, lake formation. We now have something called governed tables. And this gives you very, very fine-grained, right, like row and cell level access to your data, okay? And this extends to your like S3 buckets. So think of like lake formation as kind of a layer on top of like S3 that's giving you this governance. And so there's this new type of table called the governed table that's backed by S3. There's also a new storage API, which you should really be looking into. I know there's an open source project that was featured at Reinvent by the BMW Data Group for their data platform or sort of data portal. They're working on actually open sourcing it. I think we're going to have them on, I think, in March for this meetup. They're going to speak about when they caught wind of the new storage API actually either at Reinvent or like right before Reinvent, and they are now changing their open source project to use this new storage API. And so, pretty cool, finally get this more governed and more like granular access to our data in S3 with that new storage API. The Athena service now supports what's called the ACID transactions, of course. ACID gives us transactional support for reads or for our writes, our deletes, updates. We can also now do time travel. So with Athena, so the date that the data has been introduced into S3 can now be used as a query parameter. So we can query and say, show us data as of a particular point in time, and that comes with the Athena service, which is basically managed Presto. We can have concurrent users making row level modifications now with these ACID transactions and make sure that we're not corrupting any data with concurrent writes or deletes. This is actually built on the Apache Iceberg table format. So I had asked a question to Gary earlier, foreshadowing the fact that Iceberg was going to come up here. The Athena engine upgrade, so 3 times faster, up to 70% cost savings. These are like optimizations on top of the like open source Presto that are specific to AWS. So really, taking advantage of the like infrastructure. So here's the new storage API. Again, this gives us fine-grained access control, gives us the like ACID transactions that I spoke of here, and also, I believe there's better integration now between lake formation and the Glue catalog. So the, basically Hive metastore that stores the metadata and the schema about our data in our data lake. There's now better integration between those. Okay, so I promised a few serverless notes here. So these are the announcements that to me are very, very significant. We now have serverless EMR, okay? And so this way you're not spinning up a full EC2 instance or a cluster of EC2 instances and then letting them run unutilized. This is pay as you go. This is use just what you need to fulfill your EMR queries. Of course, as EMR gives us, Spark support, Hive support, yes, all kinds of support from the traditional Hadoop like ecosystem. Okay, very, very simple to use, and yes, AWS does all the scaling in the background, and you pay just for what you need for your queries. There's another serverless announcement here. So the managed service for the Apache Kafka, so it's called MSK, now does support serverless. And so we can very quickly scale our IO depending on the stream traffic that's coming in at that time. And of course, you pay just for what you use. Also, now Kinesis supports what's called on-demand. And this to me sounds like serverless. They've chosen to use the term on demand in the context of Kinesis. Call it what you want. This is the ability to very quickly scale out and scale in and keep your costs down if you're using Kinesis data streams. All right, we've got, I think, only about, 15, 20 more slides here. So I'm going to go quickly. RDS custom lets you run your Amazon RDS, which could be Oracle, could be SQL Server, could be Postgres, could be MySQL, but actually get down to the operating system level. So previously with Amazon RDS, you just let AWS manage it, right? Like a lot of customers, totally fine with that. Some customers do require that they get to the OS to for typically legacy reasons. They've made some kind of customization that they want to apply. And so this comes directly from customers that say, okay, yeah, we love RDS, but we actually do want to manage certain parts of it. And so this is a way. So I think currently this only supports Oracle and SQL Server, implementations of the RDS service, but I'm sure more will come. DevOps Guru, I'm going to skip through here. This is really the ability to give you suggestions on how to resolve performance issues, bottlenecks. You don't need to have any ML experience. This is actually based on years of AWS operating and Amazon.com. And so I personally love when these things come together, right? The 20 or 25 years of experience of running Amazon.com feeds into new services within AWS, which are then offered to customers. I love when this stuff happens, and in particular, performance and cost savings. So this is continuously monitoring your RDS workload and providing suggestions. DynamoDB now has some cheaper storage options. And then my favorite, I've been waiting for this for years now. We finally have serverless Redshift. Now this is in preview, but this is pay for what you use. So this is serverless. This is pay as you go BI, right? Business intelligence and data warehousing. So just want to feast your eyes on this here: automatic scaling, compute provisioning, patching, backup recovery, security, industry compliance. All this stuff is just there. You don't have, so you no longer have to think about the specific instance types that you're using or the storage. It's just there and expands as you need it. So pay as you go data warehousing, serverless data warehousing, pretty cool. Okay, just another fun slide there on that. We now have auto refresh for materialized views, query rewriting for these views as well too. So we will look at what you're trying, what query you are specifying for the materialized view for your Redshift. queries, these like complex queries where you're trying to join together a whole bunch of tables, we can actually rewrite and then optimize those queries and then continually automatically time or like refresh the data that comes back. So here's a quote from Home24 talking about using Tableau with this new materialized auto query rewrite and refresh feature. So pretty cool stuff, performance optimizations. There's a new Redshift query editor. Now has these like Redshift like notebooks basically. If you've been using the Redshift query editor, you'll know that there were some limitations. The tabs were a little bit wonky, or things would like disappear. So the query editor v2, much more full featured, gives you better schema views and lets you actually create and share these notebooks. I call them sort of mini notebooks. They're not notebooks like we traditionally think of them as in the data science world, but pretty close and cool with the collaboration feature. All right, let's round out this talk with some new launches here. We have a new training specific EC2 instance type called Trainium. Kind of a boring name, kind of a silly name, but I've gotten used to it. So this is sort of a complement to the Inferentia chip that is also kind of goofily named, that came out maybe 1 or even 2 years ago. This is now training specific. And if you're familiar with like TPUs for training in like the Google world, this is what this reminds me of. And then this is the actual 800 gigabit networking instance type that I was thinking of earlier. So this really is for large scale, massive distributed training jobs that need high speed throughput between the nodes in our cluster. Okay. And yeah, pretty cost efficient. I'm sure these are on the higher end in the sort of absolute cost, but if you look at the savings that you'll get from, because maybe it's cheaper to run 2 of these Trainium instances versus 8 GPUs. I don't know. Have not run any benchmarks. I'll be curious to see how those come out in terms of cost benefit. This does say most cost efficient. I'll believe it when I actually see the benchmarks, but pretty cool option that we finally have our own hardware and silicon that is focused on training. Inference recommender. If you've ever had sort of long-running SageMaker endpoints that are serving predictions and maybe not always serving those predictions at full capacity, and maybe scale up, scale down, you can now use something called the inference recommender that will take a look at your running workload, do some sample load tests, and tell you what you should do, if you should change instance types, or how you can optimize cost. So, like again, I love these kind of features, building trust with customers. Serverless inference, in my experience at all the talks I give, is probably the number one customer ask on the sort of inference side of things, on the prediction side of things. Until serverless inference came out just 1 month ago, customers had to spin up full like EC2 instances called SageMaker endpoints, which is what like the inference recommender will help you decide on. But now you can just use serverless inference, and all of the serverless benefits, pay as you go, pay just for what you use, is there for you. Reminder, there's been a few updates to the SageMaker MLOps strategy, SageMaker pipelines. I would just say, kind of summarize that these are more filling in some of the things that customers have been asking for, cross-account access, and maybe some small little integrations that were missing between SageMaker Clarify and SageMaker pipelines, and Model Monitor. For the most part, the big announcements for pipelines and like MLOps was really last year, And this is just, better like lineage management to see which models were trained with which data sets. And therefore, if we have to like tear down data because of like GDPR, we can now trigger retrains to retrain the models that don't use that data and things like that. So pretty cool. Here's a pretty big release that I have a few more slides on. It's called SageMaker Canvas. This is no code. This is really geared for the type of user that just wants to quickly take a look at their data sources, maybe build some quick models, do some like automated machine learning. If you were familiar with the like Amazon machine learning service that was out maybe, I don't know, 6 years ago, which was then like replaced with SageMaker, this really is sort of a throwback to that with a lot of new features and really slick UI, which I have some screenshots here. So this is sort of touted as the self-service access for machine learning. This lives outside of the like AWS console, also lives outside of SageMaker Studio. So you could actually use this and not even have to go into Studio. So that's kind of what it looks like. You can combine data sets from Snowflake, from Redshift, from S3, a bunch of data sources, visually combine them, join the data. Yeah, sorry about the text in the background. I had added these last minute. But, and we could take a look and run quick models, see which, so we would specify the column that we're trying to predict. We're saying this is a, multi-class classification, and run a quick model that can just, kind of tell me how's my data quality, which of these features are the most important, and yeah, so pretty cool stuff. So yeah, so again, this is in the context of sort of self-service, no code, and can even do it right, like graphically, which is pretty cool. And let's see, first model can be done in just a few minutes, has advanced features for feature importance and to sort of understand the model and how it's predicting. We can then export these to SageMaker Studio or share them with Studio and then dive even deeper and build more like customized models. We could do what if scenarios. Okay. And last but not least is SageMaker Studio Lab. This is a project Antje and I were working on for the last year or so. And this is absolutely free. It's free GPUs. If you're familiar with Google Colab, very similar to that, but you get, I think, 25 gigs of disk space. You get GPU access. You can go in there. You could pull down projects. So there's a bunch of sample projects that we have out there for either natural language processing or things like computer vision or just basic things like XGBoost and classification. And these models are ready for production. So this is what's tied into the hackathon, by the way. So you could use this for free. You can train your models, and this is what it looks like here. I don't think we're gonna have time for a demo because we're already way over, but you could sign up if you just Google for Studio Lab, SageMaker Studio Lab. You'll get to a link, sign up and submit your models for the hackathon. So thank you so much. Antje, any questions I should address?
We had a few questions in the chat. I think I answered them all here. So yeah, Canvas UI looks like a BI UI rather than ML. That's exactly what it should be. Yeah. So for people that are not familiar with machine learning, not working in IDEs, but more kind of a dashboarding business analyst's role. So that's exactly why Canvas as a no-code tool is a little bit cleaner in the UI and more targeted for those users. Yeah, I think I answered most of the questions along. Yeah, looks good. And we had a lot of people sticking around. So thanks everyone for hanging in there. We ran over a little bit here, but we hope you found it useful.
Awesome. And do we have a heads up on what we're going to do next month? Is there any?
We're finalizing the agenda for next month. We've been working already on the March agenda.
Yeah.
We'll send out the update in the next few days, and we'll also be posting the recording of today's session on our YouTube channel.
Cool. And thanks again to Gary, who I see is still online here. Thanks for sticking around.
Thank you. Thank you.
And we'll see you next month, third Monday of each month. So
Thanks,
have a good
everyone.
rest of January.